Hi everyone, this is Ramakrishna. Welcome to my channel. In this video, I'm going to discuss CSIR NET December 2018 real analysis question number 21 from part B. And the question is, consider the map F from Q to R, means the set of all rational numbers to the set of all real numbers, defined by f of 0 is equal to 0 and f of r is equal to p by 10 to the power q, where r is equal to p by q with p belongs to z and q belongs to n. Means p is a integer and q is a natural number, and GCD of p comma q is equal to 1. Then the map f is dash, and the four options are: option number 1, 1 1 and onto; option number 2, not 1 1 but onto; option number 3, onto but not 1 1; option number 4, neither 1 1 nor onto. So we have to choose one correct option from this 4. And here the question is about whether the given function is 1 1 function or onto function. So let us check the options. So coming to the solution, here given that f is a mapping from q to r defined by f of 0 is equal to 0 and f of r is equal to p by 10 to the power q, where r is equal to p by q with p belongs to z and q belongs to n, and GCD of p comma q is equal to 1. And here f is a mapping from q to r. Q is a set of all rational numbers and R represents the set of all real numbers. Before discussing the options, we will recall some results. So let us see the results. So here first we know that Q is countable set, means set of all rational numbers is a countable set, and ellip not, the symbol is ellip, suffix 0, subscription is 0, so treat it as ellip not, is the number of elements in any countably infinite set, because here Q is countably infinite set, means countable set, and cardinality of Q is denoted by ellip not, hence cardinality of Q is equal to ellip not. And similarly we know that R is uncountable, means uncountably infinite, and C called the cardinal number of the continuum. Here R is called the real continuum and is the cardinal number of the continuum, is the cardinal number of real number system R. That is cardinality of R is equal to C. And we know that ellip not is strictly less than C, that is cardinality of Q is less than cardinality of R. At this point, we encounter one of the most famous unsolved problems of mathematics. Is there a cardinal number greater than ellip not and less than C? Is there a cardinal number greater than ellip not and less than C? No one knows the answer to this question. Cantor himself thought that there is no such number, or in other words that C, small c, is the next infinite cardinal number greater than ellip not, and his guess has come to become as Cantor's continuum hypothesis. So here ellip not is strictly less than C, and there are no infinite numbers in between ellip not and C, and this is called Cantor's continuum hypothesis. Okay, and another one we have, if f is a mapping from A to B, A and B are two sets, f is a mapping from A to B, be a function with cardinality of A is strictly less than cardinality of B, then f is not onto but f is 1 1. So we will use these results to solve this given problem. And coming to the solution of the problem, here f is a mapping from Q to R, and cardinality of Q, means Q is a countable set, so cardinality of Q is equal to ellip not, and R is uncountable set and cardinality of R is equal to continuum C. And since we know that ellip not is less than C, so here cardinality of Q is less than cardinality of R. So by using this result, whenever cardinality of A is less than cardinality of B and f is a mapping from A to B, then that function is not onto function. So here f from Q to R is not an onto function. Okay, now coming to the options, here option number 1 is 1 1 and onto. So here f is not onto, so option number 1 is wrong. So we can discard option number 1. And option number 2, not 1 1 but onto. here f is not onto function, so we can discard option number 2 also. And coming to third option, onto but not 1 so here f is not onto function, so we can discard option number 3 also. So only the possible option is option number 4. So option number 4 is correct, that is neither 1 nor onto. So we will check option number 4. So for that, here trivially we get option number 4 is correct, because option number 1, option number 2 and option number 3 are wrong, so hence only option number 4 is correct. Okay, so we'll check option number 4, that is to check f is not 1 since f is a mapping from Q to R defined by f of 0 is equal to 0 and f of r is equal to p by 10 to the power q, with r is equal to p by q, with p belongs to j and q belongs to n, and the GCD of p comma q is equal to 1. This is the given definement of the function f. And here p is an integer and q is a natural number. Now in place of q, take p is equal to 10 and q is equal to 3. So GCD of 10 comma 3 is equal to 1. Now substitute the value in r, that is f of r is equal to f of p by q. Here p is equal to 10 and q is equal to 3, so f of 10 by 3, which is equal to, by definement we have 10 by 10 cube, which is equal to 1 by 10 square. So this is the value of f of 10 by 3. Okay, whenever p is equal to 10 and q is equal to 3. Now in place of p, take p is equal to 1 and q is equal to 2, then GCD of 1 comma 2 is equal to 1. Again f of r is equal to f of p by q, which is equal to f of p is equal to 1 and q is equal to 2. So f of 1 by 2, which is equal to, by definition, this value is equal to 1 by 10 squared. So that is, here we have f of 10 by 3 is equal to 1 by 10 square and f of 1 by 2 is equal to 1 by 10 square. But 10 by 3 is not equal to 1 by 2. So here f is not a 1 function, because whenever f of a is equal to f of b, that implies a is equal to b, then we say that f is a 1 function. But here f of a, in place of a we have 10 by 3, which is equal to 1 by 10 square, and f of b is equal to 1 by 2, that value f of 1 by 2 value is 1 by 10 square. But here 10 by 3 is not equal to 1 by 2, that means a is not equal to b, so f is not 1. So clearly f is a mapping from Q to R, whose cardinality of Q is less than cardinality of R. So clearly f is not 1, and here f is not onto function, and here f is not 1. So option number 4 is option number 4 is the correct one. So is it clear? I hope you like this video. If you like the video, please share, subscribe. Thanks for watching.